Alright, so there it is. The simplest heading I will write all quarter, the whole class, for any of these little videos. Just little, like last one's like 25 minutes, but whatever. You know, they say like make them like 5 to 10 minutes because otherwise your students will start playing games on their phone or something. No, I'm gonna dominate the time slot. I'm gonna own it by just talking about as much stuff as I feel like in one shot. But I am breaking it up, so I would like to make them 10-minute videos, but I don't know. I just kind of get in the flow. And this one's now on a pace to be like 45 because I won't shut up about videos, so that's cool. So pH. Before we get into the math, let's do a little explanation of some stuff first. So water actually self-ionizes. So there's actually always some H3O plus in water. So if I have two waters, which we tend to have way more than two, this will happen. But not with all of them, right? See how it's an equilibrium process? And this side is very heavily favored. So it doesn't happen very often. So, you know, what does it mean? Well, if I just have pure water, and it's at just regular room temperature, the concentration of H3O plus is 10 to the minus 7 molar, which means that the concentration, which I'm going to introduce these square brackets now, that means concentration of OH minus is also equal to 10 to the minus 7 molar. Just so you know, like, can't have this without this in this situation. We start shifting the balance of those by adding acids and adding bases. But pure water has H3O plus in it. It has H pluses that are associated with waters. This happens. So every now and again, waters are floating around, they collide, boom, and you get an OH minus and H3O plus, and then boom, they'll collide, and then you get two waters again. But every now and again, they collide, and then whoop, that happens. Gotta have my 3 hydrogens, right? You guys know my system. You know what I'm thinking, even though I don't say it, right? You can read minds through time and space and internet because it's on video. Alright, so this is where neutral pH comes from. So the definition of pH, here's the formula. Negative log base 10 of, whoops, square brackets. Or you can say, I mean, this is the same as saying this. So this is where it comes from. So I mean, this is what we have in solution, kind of. So you have that H plus, that like extra H plus, and so it's not like they just bump and then boom, OH minus and H3O plus. What really happens is you have a water, you have an extra hydrogen, and there's actually like 20 waters associated with that extra hydrogen. But you know, the lazy thing to do is just say, oh, there's one associated with it. So the reality is a little more complicated, but this is more correct than this. So, but they mean the same thing. So just be aware. Whether I say H3O plus or H plus, I'm talking about the same thing. This is happening in water. So this is where it comes from. So, you know, P of whatever equals the negative log of the concentration of whatever. And then for, you know, this one's for the children of the 80s. I thought of it last summer. I'm very proud of myself. I'm actually too young for this one. Man, that's terrible. So it says skull. That is power of gray skull, because pH means power of hydrogen, P of whatever concentration. So it's the negative log of gray skull, but it means power of gray skull. That's where the P comes from. Alright, so if this is our concentration, so pure water has a pH of 7 because our concentration of H3O plus of pure water equals 10 to the negative 7. The negative log of 10 to the minus 7 equals 7. So 10 to the negative 7, you take the log of that, that's negative 7. We multiply by negative 1, we get 7. Now, I'm going to give you options here in a little bit. If you can do them in your head or estimate them, cool. My advice is grab a calculator. Where's mine? Where's my calculator? This is my ancient TI from a different era. The internet looked very different when I got my calculator. I think it's in my office at work. I still use this. I've used the same TI calculator, TI 83 Plus, for 20 years now. Wow. I have a calculator older than some of you, probably. I used to have a backpack that was older than some of you, but it got a lot of use. It wore out. The zippers finally died. My wife hated that backpack. But yeah, anyway, she was very happy to see it finally go, because like the holes, like it had a leather bottom, so it's like a canvas backpack with a leather bottom, and it was so old and so heavily used. I mean, I used it through all of high school. I used it through all of college, all of graduate school. I'd bike home to graduate school and home from grad school every day with this backpack on. I mean, I used this backpack a lot. And so the leather actually wore out on the bottom and had these big holes in the corners where books would rub it, and they were just getting bigger and bigger. And I was like, oh man, I'm gonna have to like patch that bottom. She's like, no, don't you dare. And then the zippers went out because I'm pretty sure she sabotaged them, because that thing was immortal. Nah, I mean, it just got old. Zippers died. That was into the backpack, and she immediately bought me a new backpack before I could even think of saving that backpack. So now I have one that's like all fancy. It has more pockets I know what to use, and I lose stuff in it. It's too much for me. I'm a simple guy. All right, none of you cared about that. That's cool. Hope you enjoyed your backpack history lesson. So, find the log button. So what does the log button look like? It'll look like this or like this. And it'll probably be like log x or log base x. It'll just be a little button on your calculator. And my advice is just know how to do that calculation. So if you can get this to come out as 7, you know how to do it on your calculator. And just be able to do that over and over again. Or you can estimate. You just take whatever the power of 10 is. If there's nothing in front of it, if it's just something to the power of 10, you take that and you flip the sign. So negative 7 becomes 7. That's the other trick. So that's how you estimate. That's half of how you estimate. Alright, so a pH of 7 is what we call neutral. It's a neutral pH. Now if we add acid, well, that means that we're going to increase our H3O plus concentration. I like how I just slid into using that notation, by the way. Square brackets equals concentration in molarity. Well, that's going to equal pH going down. They're an inverse scale. That should be a lowercase p, by the way. My fault. So, lower than 7 equals an acidic pH. And pH can go negative too. You can have like a pH of -1. You can have something that's really acidic. Alright, now if we are adding base, that means that we're going to get rid of H3O+. Not necessarily entirely, but we are going to definitely lower how much there is. That means that pH goes up. And we'll do some math here to demonstrate what I'm talking about. And so, a higher than 7 pH is basic, or sometimes it's called alkaline. Either term's fine, whatever you're familiar with. Alright, so what am I talking about? Well, let's practice. Alright. what is, I just realized I'm not going to be able to do logarithms in my head, so let me go here. Alright, so what is the pH of a 0.015 molar HCl solution? Okay, it might look like I'm not telling you everything here, but remember, this is a strong acid, so what this is saying is this is a 0.015 molar H3O plus solution. Because all those HCl's are going to become H3O pluses. Okay, and then I'm just going to set up my formula. Okay, I know my H3O plus concentration. And I'm going to do a little trick here. So you could punch this in your calculator, and you're going to get a number. And that number is 1.82. I'm not going to be a big bully on sig figs here, because they're kind of, the sig fig rules for logarithms is kind of stupid. I'm serious. So I have 2 sig figs, that means I get 3. You just add 1. So it's kind of made up. So whatever, just be reasonable. I'm not going to bully you on this. Or I can rewrite this and go log of 1.5 times 10 to the minus 1, 2. And that's how I want to look at it to estimate it. And so this is going to be somewhere between, well, we already know it's going to be between 1 and 2, but I see like, okay, it's going to be 2. So it is approximately between 2, and then it's a 1.5, which actually means that, remember, as this number goes up, pH goes down. So it's between 10 to the negative 2 and 10 to the negative 1, because that's larger. So it's somewhere between 0.1 and 0.01 and 0.001. So it's somewhere in that range. Or no, between 0.1, excuse me, and 0.01, because it's above 0.01. There we go. So it's higher than 10 to the negative 2, which means that our pH is going to be between 2 and 1. So I think estimating is trickier. There's a few instructors at Lane that really like to lean on it, and I just say, just find the button on your calculator. I mean, look at that, you just go bam. So practice the ones you know. Like, you should be able to get this number. If you're not getting this number, you're goofing on the calculator somehow. You just got to sort that out. Same with the 7 before. You should be able to get the 7. And once you know how to do it on your calculator, you can solve all of them. Alright. What else can we practice here? Oh, we'll do one more like this, and then we're going to go the opposite direction. We're going to use pH to find concentration. So, if our concentration of, and I'll just be real straightforward with this one, I'm not going to make up a whole story. 1, 2, 3, 4, 5. Okay. 0.12345 zeros and a 1. Well, I can also say this is 10 to the negative 6 molar. Right, because I can go 1, 2, 3, 4, 5, 6. So 10 to the negative 6. I just converted it into scientific notation. Alright, my pH is going to equal negative log of 10 to the negative 6. That's going to be 6. Don't even need to estimate, like I know it's 6. Or you can punch in your calculator and get 6. However you're comfortable with it. Alright, so last thing we're going to talk about in this video. Finding the concentration of H3O plus from pH. So this is like you use a pH probe or something like that. You measure the pH. You want to know how much acid there is in terms of concentration. Well, for every math operation there is an opposite, right? Addition has subtraction, multiplication has division. Logarithms have exponentiation. And so if pH equals negative log base 10 of concentration of H3O plus, then we're not going to do a whole derivation. We'll just say concentration of H3O plus equals 10 to the power of the negative pH. So this is 10 to the power of negative pH. So how do we solve one of these problems? Well, if we have a pH equal to 8.0, what does our concentration of H0 plus look like? By the way, could I write an example problem any lazier than that? Good lord. There's no complete sentence. It doesn't get any, that might be the only wasted motion in the whole thing. And you know it's a question because I ended it in a question mark, so you're welcome. There you go. Alright, punctuation. Yeah, I still work punctuation into it. Alright, so I know my pH. Guess what I do? I just use this formula. And I just go, oh, okay, well, my H3O plus concentration. And so there's going to be a button on your calculator, by the way, that's going to look like 10 to the x, probably. That's how you input this. Or you go 10 caret. The calculators do it different ways, but know how to do exponents. So if my pH is 8, then I have 10 to the negative 8.0, and guess what that is? That's just 10 to the negative 8. You get to eat a number. Alright. That's my concentration. Very low concentration. By the way, is that an acidic or a basic solution? pH is above 7, it's a basic solution, so it's a very low, still has a concentration of acid, but it's very low. Very low. Alright. We'll do one more here. What if pH is equal to 3.7? Then what's our H3O plus concentration going to be? Well, this one you might have been able to do in your head. I mean, it doesn't get any easier than that, right? You probably didn't need to use your calculator on your button. If you did, you just ended up going, you're like, oh, it was 0.1234567 That works, sure. But you can also just write that. That's cool. I'm fine with 10 to the negative 8. You don't have to convert it. You don't have to do that. You can. It's not wrong. I won't bump you for it. And I won't knock any points or anything. Alright, so we'll just use our formula down here. This one, let's get a number. Okay, so you're going to punch it in your calculator. You're going to use, it probably looks like this. There should be a button that looks like that on your calculator. And sometimes you input the negative 3.7 first, or sometimes you hit this and input the negative 3.7. Different calculators have different kind of order of how you do things. Or sometimes you see a caret button. That might be the other button you use, in which case you'd go 10, caret, negative 3.7. And you should be able to get the following number of 0.0002. These are molar, by the way. So however you get there, get comfortable, be able to repeat it, and be comfortable just doing it on the fly, and you're good. You can solve any of these problems. I mean, it's just two formulas. There's kind of the forward, calculate pH, and the backward, take pH and calculate concentration. Concentration to pH, pH to concentration, and then understanding the pH scale. So 7 is neutral. We talked about Y as well, so it's good to understand why 7 is considered neutral pH. We go below, that means that we're adding acid. So it's the opposite of the H3O plus concentration. When that goes up, pH goes down. If the pH goes above, we have a basic solution. It has base that's been added to it. Or an alkaline solution. That's another common term for it. Again, whichever. Alright, so we are going to talk about another pretty fun idea in the next video. So it's going to be 100% relying on the ideas we just talked about, like pH, and we're going to tie in equilibrium to it. I told you, it's crown jewel. It means it starts to show up a lot. Equilibrium is incredibly important to chemistry. So, what we're going to talk about are pH buffers. Alright? That's what we're going to talk about next.